All right, guys, today we are going to move on into the properties of logarithms. So yesterday when we looked at 7.3, you got to study what's called a logarithm. And a logarithm is technically an exponent. It's another way of writing it. And the cool thing is logarithms allow you to solve exponential equations. Okay, today we're going to specifically be looking at the properties, and because logarithms are exponents, you can derive the properties of logarithms from the properties of exponents, and you already know those because we studied those a lot at the beginning of the year. Okay, so remember, if you have the same base and you are multiplying, multiplication goes with addition. So what you do is you write the base once and you add the two exponents together. So for example, if I have x to the power of 3 times x to the power of 4, you would never leave this as a final answer because you don't want the base to be shown 2 times. Because the bases are the same, you write the base once. Multiplication goes with addition. So I take those two exponents and you add them. So x to the power of 3 times x to the power of 4 is x to the power of 7. So again, that is a property of an exponent that they are going to use to figure out a property for a logarithm. And the idea here is same base, multiplication goes with addition. So one of the skills that we'll be doing quite a bit of is condensing logarithms. So this is a log base 3, this is a log base 3. So again, you don't want to have two logs in the final answer with the same base. You are adding. So you write the base once. So I write log base 3 one time. Addition goes with multiplication. So I take the 10 and the 100 and I multiply them. So your condensed version of this would be log base 3 of 1,000. These two things mean the same thing. It's just knowing you want the base to occur only once. Adding goes with multiplying. Okay, and again, we will have times where we're going to go the opposite way. You can take a single log and expand it, knowing, again, that multiplication would go with addition. Okay, so let's go ahead and look at these. Knowing that adding goes with multiplying, let's practice this. It says to express it as a single logarithm, so what we're doing is called condensing. Then simplify. When they say simplify, that means solve it. So go back to the skills from 7.3 and figure out what that value would be. This is a log base 6, this is a log base 6. So we can write it as one single log base 6. Adding goes with multiplying. So I take the 4 times the 9 because it's addition here. Adding goes with multiplying, so you multiply them together when you're condensing. So this would be log base 6 of 36. That is your single logarithm. Now when they say simplify, when they do that with logs, what they really want you to do is evaluate. So 6 to the power of what equals 36? What exponent could I put on the base to get to the large number? Well, that would be a 2. Done. So we combine these into 1. Then we simplified by knowing what exponent you could put on the base to get to the larger number. Okay, let's look at the next one. Log base 5, log base 5. Because they have the same base, that's why I can write it as 1. Adding goes with multiplying. So 625 times 25. So log base 5 of 625 times 25, we have 15,625. 15,625. There is the single log. Now, obviously, some of these you won't be able to do in your head, okay? So let's just go ahead. 5 to the what power would get me to 15,625? I'm going to go 5 to the power 5. Nope, that wasn't enough. 5 to the power of 6. Hey! So the value would be 6 because 5 to the power of 6 gets you to 15,625. Okay, let's look at another one. Log base 1/3, log base 1/3. Because they both have the same base, I can condense them. Adding goes with multiplying. 27 times 1/9. So I have the log base 1/3. 27 times 1/9 is the same thing as 27 divided by 9, so that's a 3. Here is your single log. So this is 1/3 to the what power gets you to a 3? we don't want to change the value of the 3. We just want to flip the fraction upside down. We want 1/3 to become 3 over 1. In order to flip a fraction, you need an exponent of -1. So there is a property of a logarithm. Super fun. Okay, now here is another property. Same thing. You do not want the same base on both the top and the bottom of a fraction. Remember, fraction means division. And we learned back when we were studying exponents that division goes with subtraction. Okay, so if you have the same base on top and bottom, you write the base once. Then you subtract top exponent minus bottom exponent. So here's an example. If I have x to the power of 5 over x to the power of 2, you don't want this as your final answer because it's not simplified. You can't have x's in your solution more than once. So I write the base one time. Okay, so it has a base of x. You take the top exponent minus the bottom. And it is that way 100% of the time. It's always top minus bottom. So x is your base. 5 minus 2 is 3. This is the same thing as x to the power 5 over x to the power 2. The difference is this is not simplified, this is. This property, when you're looking at logarithms, is very similar. So if I am condensing, it means I'm going from here to here. Log base 5, log base 5. Because they both have the same base, you can write it as a log base 5. Subtraction goes with division. So it would be the first value divided by the second value. So 16 divided by 2. And again, there will be times as we move throughout the chapter that we may have to expand it. And in fact, in the second part of 7.4, we'll be taking something like this and writing it out in this format so that way we can study earthquakes. Okay, so all of these properties do go forwards and they go backwards. For today, because it's just the first day, what they're having us do is go ahead and condense. So let's go ahead and do that. This is a log base 5, this is a log base 5. So I can write this as 1 log with the base of 5. Subtraction goes with division. So I take 100 and I divide it by 4. I can simplify that further. Log base 5 of 100 divided by 4 is 25. Okay, so we wrote it as a single log. Now simplify. 5 to the what power gets you to 25? 2. Now let's go again. Log base 7 and log base 7. Because they have the same log, that's why you can condense them, or they have the same base. So I write 1 log base 7. Subtraction goes with division. So it's 49 divided by 7. So log base 7, 49 divided by 7 is 7. 7 to the power of what gets you to 7? 1. So there are your two solutions. Last one like this, guys. Log base 2 and log base 2. So I get to write it as 1 log with the base of 2. Subtraction goes with division. So it's 32 divided by 4. Log base 2, 32 divided by 4 is 8. So there's your single log. Now when you're actually going ahead and evaluating it, 2 to the power of what gets you to 8? That's a 3. So there is our second property. Okay, here's the next one. Now the next one, there is like a shortcut as to how it works, but it is important for you to see why it works the way it is. Okay, so I'm going to go ahead and let's say I have log of 10 to the power of 3. Okay, so 10 to the power of 3 means that I have that 10 3 times, right? So it'd be log 10 times 10 times 10. Well, multiplication goes with addition. So what I could do is take the log base 10 plus the log base 10 plus the log base 10, because I can expand this. Well, these are like terms, and we will talk about that coming up in this chapter as well. These are like terms. Log of 10 plus log of 10 plus log of 10 gives me 3 logs of 10. So here's the long way of looking at this property. They shorten it up by saying if you have an exponent on a logarithm, what you want to do is bring it out front. Because notice, if I just said, oh, I have an exponent here, if I bring it out front, that's where the problem ends. So exponent on a log comes out front as a product. You are multiplying it. So using variables, if I have log base b of a to the power of p, p is an exponent on a log, so it comes out front, so it's p times the log base b of a. So again, it is a product, exponents come out front. This is why it works the way that it works. Okay, let's go ahead it says to express each as a product. So again, we're just going to go ahead and practice this property. There is an exponent, so I bring it out front. So this is 6 times log base 2 of 32. So this is as a product. That's the first thing. Then simplify if possible. So this is 6 times 2 to the power of what is 32? Well, 2 to the power of 5 is 32. So this whole thing has a value of just 5. I can take log base 2 of 32 and just replace it with its value, which is 5. 6 times 5 is 30. Done. Okay, let's look at B. This one is a little bit tricky. Okay, you are at a level of math where they're going to throw in some challenge questions. So 20 times log base 8 of 4. This is your product. 20 times 8 to the power of 4, or 8 to the power of what gets you to a 4? Well, 8 to the power of 1 is 8. If I go negative, it's just going to turn it into a fraction. If I take it to the power of 1/2, that would be a square root, but 8 is not a perfect square root. But check this out. If I take 8 to the power of 1/3, okay, because that's what the base is. 8 to the power of 1/3 is the cubic root of 8. Well, the cubic root of 8 is 2. Well, in order to turn a 2 into a 4, you would square it. So 8 to the 2/3 means you would take the cubic root of 8 and then square it. Well, the cubic root of 8 is 2. 2 squared is 4. So this is 2/3. Again, this is a challenge question. You are not going to see very many things that look like this, but I think it's important for you to see that you do have to remember, like if you have an exponent to the 1/2, it's a square root. If you have an exponent to 1/3, it's a cubic root. Those things don't go away as we add new ideas. So I thought it was important for you to see one like this. Okay, now if you multiply top times top, bottom times bottom, 20 is the same thing as 20 over 1. So this is 40 over 3. Okay, let's look at the next one. Exponent comes out front as a product. So it's 4 times the log of 10. Now when you are going ahead and finding the numerical value, what is it actually worth? This log does not have a base. Remember, if it doesn't have a base, it's an unwritten 10. So 10 to the power of what gets you to 10? That's 1. 4 times 1 is 4. 2 more. My exponent is a 2. Exponents come out front. So 2 times log base 5 of 25. There's the product. You rewrote it. Now we evaluate it. 2 times 5 to the what power gets you to 25? Well, that's a 2. 2 times 2 is 4. Last one, practicing this property. Exponents go out front. So it's 5 times log base 2 of 1/2. There is the first part. That's expressing it as a product. Now to evaluate it, it's 5 times 2 to the what power gets you to 1 over 2? You want to give 2 an exponent where that 2 gets put on the bottom, so it would be a -1, because negative exponents put the value on the bottom of a fraction. 5 times -1 is -5. So far we have looked at 3 properties. Now the next properties, these ones, you guys, it's so fun. Now these are inverses where you get to just totally cross things off. So when you are looking at inverse operations, what that means is that they undo one another. So if you ever have a log where the base and the big number are the same, they cancel one another. All you'd have left is an x. If you have an exponential form of that where the bases match, so b to the log base b, if you have an exponential base and a logarithmic base and they connect, or they are the exact same thing and they're next to each other, they cancel. All you would have left is an x. That's why x is your answer. So numerically, if you looked at this, log base 10 of 10, because the base and the big number match, they cancel off. All you have left is a 7, so that's a 7. These two things totally just undo one another. 10 to the log base 10, they undo one another, so all you'd have left is a 2. So let's go ahead and look at some of these, okay? Hey, log base 3 of 3, these undo one another, all you'd have left is an 11, you're done. Now again, this is like a challenge question. You have to realize that they're not always going to be set up for you. 81 is the same thing as 3 to the power of 4. 3 to the power of 4, see if I check this out. 3 to the power, oh, here we go. 3 to the power of 4 is 81. So I can go ahead and rewrite 81 as 3 to the power of 4 because now the little number, the base and the big number match, they undo one another. Your answer is a 4. 5 to the log base 5. Hey, the bases match. They undo one another. All you have left is a 10. If you do not have a base, it is an unwritten 10. Log base 10 of 10 cancels. Your answer is 0.9. Hey, 2 to the log base 2 cancels. It's okay if you have a variable in your answer. That's what you have left. Same thing here. Log base 8 of 8 cancels. Your solution is 3x plus 1. It's okay to have variables. It's okay to have more than one term. You just have to know what things can undo one another. So you can simply just cross them off and forget about them. Super cool. Next page. Okay, now on your calculator, you will see that there is a log button. And I showed you this in 7.3, but just in case you forgot, okay? Here is the second key. Here's the log button. Notice that it does not allow you to put in a base. What this means is that it is a log with a base of 10. It is the common log. Well, if you want to use a calculator and you have something like this, you can't put it in the calculator because these have bases other than a 10. So there is a property, it's called the change of base formula. And what it does is it allows you to rewrite a log that does not have a base of 10 into a format where it does have a base of 10, and then you can calculate it, okay? So if I have a log base b of x, a, notice that they're changing the base. A can be any base. Well, we are going to use 10 because if you change it to a base of 10, then what that does is it allows you to use the calculator. So again, this could be any base you want. Okay, so log of any base, you take it to the x over the log of whatever base you choose to the base. So if I'm doing 10, it will be log base 10 of x over log base 10 of b. The way that I remember the order, the base of the original goes on the bottom, bb. The base of the log goes on the bottom of the fraction. So let's go ahead and do some of these. This will allow us to enter it into the calculator. So I have a log of 8 over a log of the base, which is 32. This is what the change of base formula is. It's the log of the larger written number. It doesn't always have the largest value. It's the largest written number. So the log of 8 goes on the top. The log of the base goes on the bottom. Now you just plug this into your calculator. So the log, it'll open a parenthesis for you. We want the log of 8 on the top. Close it. That's the numerator. Divided by, we have a log on the bottom. The log of the base, which is 32. It'll open a parenthesis for you. Make sure you close it at the end. And this is 0.6. So what this tells us is 32 to the 0.6 power gets you to 8. Change of base formula, we could use the calculator. Okay, let's look at the next one. Log of 27 over log of 9. Again, make sure that the base was a 9. That's the one that's on the bottom. Go ahead and enter it. Log of 27 divided by the base is log of 9. We have 1.5. So this means 9 to the 1.5 power gets you to 27. Let's look at another one. Log of 16 over log of 8. This is change of base formula, being able to rewrite it as a fraction. Now you can calculate it because it's a base of 10. Log of 16 divided by the log of 8. 1.3 repeating. Or you could write it as 4/3. So that's cool. It's a way that you can take something that maybe wouldn't be easy in your head to solve. It does not currently have a base of 10, so without rewriting it using that formula, you would not be able to use the calculator. So change a base formula, if they ever ask you to use that property, there are 2 steps. Step 1 is you have to rewrite it as a fraction. That's what the change of base formula is. Then from the fraction, you can put it into your calculator. Okay, so tomorrow is a work day. There is also a Zoom call. If you have any questions on any of these questions, that's a lot of questions. Okay, if you have any issues as you're working through 1 through 18, 20 to 34 and 40 to 45. Please make sure you look and see what time the Zoom is for your class. Join me, ask some questions. We can do some math together. But again, tomorrow is a work day on this, so we will not look at any new concepts. I just want you to take a full day and just practice. I hope you guys are doing well, and I'll talk to you soon. Bye.